Okay, so here's your second level 1 video for A.REI.3. Now we're going to be talking about inequalities and solving inequalities. So an inequality is a mathematical statement that's going to use something called an inequality symbol to compare two values of expressions. So hopefully you guys have seen these inequality symbols before. So we use this symbol to describe less than. So if I have 5 and 6 to compare those two numbers, I can use the less than symbol. I can say 5 is less than 6. And then we have the greater than symbol. If we are comparing two numbers, -2 and -4, well, -2 is greater than -4, so we would use that greater than symbol. A little trick here, and something you might have learned before, is that the wide part, you can think of the inequality symbol as an alligator's mouth. And the alligator's very, very hungry and wants to eat the larger number. So the alligator mouth should be open towards the larger number. And that's just a quick way of describing inequality symbols. And then we have the less than or equal to symbol, which means that if we have a number, let's say 2, and a number, let's say 8, well, 2 is less than or equal to 8. You can also say 8 is less than or equal to 8. The number just needs to satisfy one of the parts of the less than or equal to symbol, so it needs to satisfy the less than or the equal to part. That's why the word or is in between the less than or equal to. So it doesn't have to satisfy both the less than or equal to, it just needs to satisfy either the less than or the equal to part. And then the greater than or equal to symbol, if I have the number 0 and -1, well, 0 is greater than or equal to -1. In fact, 0 is greater than -1, so it doesn't satisfy the equal to portion of that statement. However, again, it does not need to satisfy both. Now, this next part, you might not have learned. You might have learned all the inequality symbols, but you might not have learned how to solve inequalities, like numbers 1 through 3. And a very important tip or guideline that you must follow when we are solving inequalities is you must flip your inequality symbol around when you are multiplying or dividing both sides of an inequality by a negative number. I'm going to show you why that's the case with just a little example. You don't have to take notes over this part. I just want you to listen so you understand. If I was comparing the numbers 3 and 4, the symbol that I would use to compare these two numbers is 3 is less than 4. Now let's say I decided to add 1 to both of these numbers. Then I would have the new numbers 4 and 5. And the symbol that I would use to compare the numbers 4 and 5 would still be a less than symbol. Let's say I decided to subtract 2 from both sides now. Now I would have the numbers 2 and 3. And the symbol to compare these two numbers together would still be a less than symbol. Let's say that I decided to divide both of these numbers, or let's do multiply both of these numbers by 2. Well, I would now have the numbers 4 and 6. And to compare these two numbers, I still would have a less than symbol. Let's say I decided to multiply these two numbers by -2. Now I would have the numbers -8 and -12. To compare these two numbers together, -8 is actually greater than -12. So when I multiplied by a negative number, my inequality symbol flipped around. However, when I added a number or subtracted a number or multiplied by a positive number, my inequality symbol stayed the same. It stayed as a less than symbol. But as soon as I decided to divide by a negative number, multiply by a negative number, my inequality symbol flipped around. Let me show you when we divide by a negative number what happens. So let's divide both of these numbers by -4. I wind up with the number 2 and the number 3. To compare these two numbers together, 2 is less than 3. So guess what, guys? When I divided by a negative number, my original my symbol from the previous set was a greater than symbol, and it flipped around now to become a less than symbol again. So I just showed you that when we divide or multiply both sides of an inequality by a negative number, your inequality symbol flips around to keep the statement true. That's exactly what is happening when we're solving inequalities. If we ever multiply or divide both sides by a negative number when solving an inequality, we must flip our inequality symbol. So let's get started. Numbers 1, 2, and 3, we are going to solve these inequalities exactly how we solve an equation, with the tip in mind that when we multiply or divide by a negative number, we do need to flip our inequality symbol. So in number 1, I have a -5 times a y and then a -2. I'm going to still do the order of operations backwards, still use inverse operations. I'm going to first start off adding 2 to both sides. When I do that, I have a -5y and a -2 plus a 2 cancels out, and I'm left with, I added a 2, so my inequality symbol does not flip, and 8 plus a 2 is a 10. Now I'm going to want to divide both sides by a negative number. But this should trigger something in my brain. When I'm dividing by a negative number on both sides, guess what, guys? My inequality symbol is going to flip around. So right now it's a less than symbol. It needs to flip around to a greater than symbol to keep my sentence true. A 10 divided by a -5 is a -2. This is my solution. What this solution means is if we put any number greater than -2 into my original inequality, then we would get a true statement. So if I put 0 in for y, I would wind up with a true statement. If I put -1 in for y, I would wind up with a true statement. Any number greater than -2 is a solution to that inequality. All right, number 2, remember we must simplify before we solve and start moving things. So I'm going to do a 30 is greater than. Now I am multiplying by a negative number here by distributing this negative number in, but I'm not multiplying by a negative number on both sides of the inequality. So keep that in mind, we're not flipping the symbol. I still need to simplify. I'm going to simplify the -5x and the 10x. So I wind up with a 30 is greater than a 5x minus 15. Now I'm going to add 15 to both sides. So I wind up with a 45 is greater than a 5x. And then now I'm going to divide 5 by 5 on both sides. I'm dividing by a positive number, so I do not flip my symbol. I wind up with 9 is greater than x, which, if you want to write your variable on the left side, then you flip your entire statement around. Notice that the alligator is open towards the 9, so if I want to flip my entire statement around, the alligator mouth still needs to be open towards the 9, So I could either leave my answer as 9 is greater than x or x is less than 9. Those two statements mean exactly the same thing. You do not need to write both, but I wanted to show you that those are the same thing. So any number less than 9 would satisfy this inequality. All right, moving on to number 13. We don't need to simplify anything. So I'm going to get this 13 over to the other side. Since it's a positive 13, I'm going to subtract it over. So I have a negative 11d is greater than or equal to a negative 66. Now I'm going to divide by negative 11 on both sides, and since I'm dividing by a negative number on both sides of my inequality symbol needs to flip around. So it was a greater than or equal to sign, now it's a less than or equal to sign, and a negative 66 divided by a negative 11 is a positive 6. So your answer is D is less than or equal to 6, which means any number, 5, 4, 3, 2, 1, any number less than or equal to 6 could satisfy this inequality, including 6. If I put 6 into this inequality, it would come out to be a true statement. All right, we have solved all these inequalities, but did you know that you could graph your solution to an inequality on the number line? Well, you can, and we're going to do that now. So step 1, after we fill out the numbers on our number line, what we're going to do is we need to determine, should we have an open or a closed circle on the number that's involved in our inequality on the number line. So we use an open circle for when we use a less than or greater than symbol. This means that your number is not a solution, part of your solution. But we use closed circles when we have a less than or equal to or a greater than or equal to symbol, because this means that your number that's involved in your inequality is a solution. And then we're going to shade part of our number line to makes our inequality true. So numbers 1, 2, and 3, it says graph the solutions to the inequalities that you found in 1, 2, and 3. All right, so in number 1, my solution is y is greater than negative 2. So we need to fill out our inequality number line, we need to fill out our number line. We can start with 0. Going to the right of the number line, the numbers should increase. So 1, 2, 3, 4, 5. Going to the left of your number line, the numbers should decrease. So negative 1, negative 2, negative 3, negative 4, negative 5. This is just a standard number line. Now the number that's involved in my solution to number 1 is a negative 2. However, that is not a solution to my inequality because there's no equal to sign involved in my inequality. So since it's just a greater than symbol, that means we have an open dot at negative 2 on my number line. And then it says we want y is greater than negative 2. So we want all the numbers that are greater than negative 2, which is shading to the right, to be shaded in. All these numbers, including numbers beyond this number line, are solutions to your inequality. All right, number 2, the number that's involved in my inequality is 9. So we need to make sure our number line goes up to 9. So we don't have to start at 0. We can start at, let's start at 7, 8, 9, 10, 11, 12, and then we decrease going to the left. All right, now I want an open dot on 9 since I have a less than symbol. There's no equal to sign involved. And then my answer is x is less than 9. So that means all the numbers that are less than 9 on this inequality, which is to the left, should be shaded in on this number line. And then lastly, we have 6 involved in my last inequality. So I'm going to create my number line right now. And since there's an equal to sign in my inequality, we're going to have a closed dot because 6 can be a solution. And it was D is less than or equal to 6, so we want to shade all the numbers less than 6 as well. And that brings us to the end of this lesson.